Hello everybody, and happy Saturday. Welcome back to our weekly show. Just wanted to say, sorry about the late start this evening. Actually, I was also following the rocket launch today, so I was doing some math that was something, I was a little bit curious about something related to rockets. Actually, that's what I wanted to share with you today. If you're new to this weekend show, I want to tell you what you're in for. What we do here is I talk about something that I might have been a little bit curious about this week. And as you know, there has been major news that happened today, and that was the rocket launch. A very successful rocket launch by SpaceX, which sent 2 astronauts up towards the space station. Very interesting. Actually, it was quite something to watch as well. And what we always do on this weekend show is we talk a little bit about some mathematical insight, and then after that, I open up for questions, and the questions can range over anything, which is also a very fun part of this particular show. Now, the way I choose these questions, the question that I talk about, of course, is something that I am actually curious about. And so maybe some of you were also watching the rocket launch today, and I thought it was really interesting how as the rocket took off, it felt like very soon after it took off, you could sort of see the Earth as a round thing behind you. I don't know if anyone else had that impression as you were watching the rocket launch. Because to me, it's like, look, if I climb on top of a ladder, I don't really notice anything special other than I'm about to fall down. If I go into the top of a skyscraper in New York City, I feel like, yes, okay, I'm high up, but the Earth still looks pretty flat. But I don't know if any of you noticed this, but like really quickly after they launched in that rocket, it just felt like they were looking back down on Earth. And I was a little bit curious, how can that be? So I came up with this question that I want to share with you. It's actually something that I was curious about. Astronauts are on the way to the International Space Station. They quickly reached an altitude of 100 kilometers. Let A be their distance to the farthest point on Earth that they can see. Let B be their distance from the International Space Station at an altitude of 400 kilometers to the farthest point on Earth that can be seen from there. Estimate the ratio B divided by A. Now, this particular question is somewhat related to what I was talking about. What I was talking about was like looking back at the Earth and saying, wow, the Earth looks kind of round. How far on the Earth could you see? So I was very curious and I just started thinking about this. Now, as you know, if you've seen these live streams before, there's some time for people to play with a question, and we'll have about 3 minutes for you to play with it, during which I make some comments that maybe can explain to parents or coaches who are watching how one would think of this and also why this question is picked. So it's important that this happens to be designed around something that happened today, which is a space launch that had so many people on Earth paying attention to. And so that's one characteristic that can make a good question. It's that you, as a coach or a teacher, watch something and then think, is there anything nifty about what you just saw mathematically? And then you just sit down and think about it. Now, a question like this, though, has more in it. It's not only a question that's interesting from this application point of view, it's also a question that's interesting from a mathematical point of view. So this is going to give people a chance to play with some geometry. But probably something that seems a little weird right now is there's not enough information. Is there? Well, I don't know. We're gonna talk about a few different ways to do this problem. But regardless, I will give you hints along the way. And the hints can also make it a little bit easier maybe for you to try to solve this problem in an old-fashioned way. Because as usual, there will be multiple different ways that you could try to do the question. I also think that hints are very important because if you're going to try to think about something, if you're going to try to learn something which is hard, it's useful to fight with it for a little bit and then get a hint like this, and then fight with it a bit longer. And the way this will always work is there will always be 2 hints. But the first hint already says that you could just use 6,000 as the radius of the Earth in kilometers. Maybe that would make a way for you to try to solve this question. So that's the first hint. And a comment for parents and coaches, you will find out that the number that was chosen, 6,000, is not only the radius of the Earth, it's also very interesting from the point of view of the numbers inside this problem. Okay, so again, we're looking for the ratio of B divided by A. B is going to be the distance from the International Space Station, which is 400 kilometers up, to this farthest point on Earth that they can see. Now, I can see that students are already thinking about this. I can also see from the number of responses that this is not an extremely easy question, which was sort of the point. Aha, but there's a second hint. The second hint says, sometimes you can save yourself some work. You know, like, we would have maybe some big calculations to do with a lot of numbers. But sometimes it's useful if before you do the calculations, you try to write down, what would you actually calculate in terms of some variables or some letters, and then see if you can use that to figure out what the answer is. So this is how I go about making a question. It's somehow something that's interesting in the world. It's something that I was curious about. And it also is something that has some mathematics embedded in it that's going to let us talk about a couple of different concepts today. What do we have for answers? I see that some people have started typing. You're welcome to type your answer if you want, because we're about to start discussing how to do this question. I see that there aren't that many answers, and that means that this question is probably a pretty good challenge. And that's also the sign that the question might be appropriate. Let's see what the answer is. Okay. So I'll switch to my blackboard over here. So I see that people are having some question marks on what they think that the answer might be. But maybe we should start by trying to draw a picture. What are we actually doing here? We have the Earth. That doesn't look quite like the Earth. That looks like a lopsided asteroid. Let's try again. Maybe that's a little bit better. So let's pretend that's a nice circle. So that's going to be the Earth. And we also have the astronauts at some height above the Earth. Maybe the astronauts are around here. I just wanted to show that this is not even drawn to scale. In fact, if the Earth is 6,000 kilometers and this is 100 kilometers, it should be barely visible. But we just have to sort of see it. Okay? So that's why I'm drawing it not to scale so that I could see it. 100 kilometers. And from the center of the Earth, that is about 6,000 kilometers. Now, the question was asking something about ratios, and there was this farthest point on the Earth that you can see from where the astronauts are right now. What part of the circle would that be on? This is a geometry problem. I chose to do this because we haven't had as many geometry problems on the weekend live streams for a while. And so I wanted to put a geometry one to say, from here, what's the farthest point you can see? Obviously, you can see under you. And obviously, you can't see all the way over there. But you draw something called a tangent. I saw that somebody mentioned that. You draw a line that goes from that point that you're on, and it goes to a tangency point. It goes to this point on the circle where it looks like it would just graze right there on the circle. And there's some other very important fact about that tangency point. You know what happens if you draw a line from the center of the circle to the tangency point? Do you notice anything about this pink line and that pink line? Well, these two different pink lines here, these happen to be perpendicular to each other. And that makes sense because you see, if you imagine where you'd go to that point which if there was any other angle, then you could go to another point over there, because this is supposed to be symmetrical. So if I just ran this all the way through, this would just be a nice straight line, and it would be just symmetrical across that line. So I have a point of tangency, that's what it's called. Okay, so that's a point of tangency. So now I can actually figure out what this distance is over here. I saw some people said use power of a point. You could indeed use some of these other techniques in order to try to solve this problem. But, over here, I can do it with even easier techniques. So if this is 6,000, does anyone have an idea of a simpler theorem I could use? I'm interested in this length here. There's a 6,000 and there's a 100. Is there any nice thing I can do with this triangle? That's right. Pythagorean theorem will be enough. Because you see this pink line here, that's the radius also. So this is 6,000. Okay? So if that's 6,000, what do I need to figure this one out? It's going to be the Pythagorean theorem. I basically have 6,100 and 6,100. 6,100 and 6,000. Okay? Let me redraw the triangle. We have the Pythagorean theorem, and the Pythagorean theorem is going to work on this. 6,000, 6,100. Okay? But before you do that, yes, I like this. Oh, I like things says, you should take this and you should say, well, this happens to be 100 times of a picture which looks like this. Guess it's a little bit turned, but that's okay. 61 and 60. So I just need to figure out what this is. So everyone knows the way you do the Pythagorean theorem, right? The Pythagorean theorem tells you it's the square root of 61 squared plus 60 squared, right? No, not that way. Just that was just a trick question. A trick thing to do. It's not always the square root of a squared plus b squared, because this one happens to be the hypotenuse. So that's not right. What I wrote there is not right. It has to be 61 squared minus 60 squared. What is 61 squared minus 60 squared? I guess we could try to go and calculate all of these out. It is okay to use a calculator, but in this case, I guess I see some people already figured out that when you subtract these two squares, it's kind of mysterious. 61 squared minus 60 squared is 121. Wow, 11. Really? Yes, really. This is one of these nice triangles. It's the 11, 60, 61 triangle. That's actually one of these nice triangles, like how 3, 4, 5 is a nice triangle, 5, 12, 13 is a nice triangle, and 11, 60, 61 is a nice triangle also. So that means that this length here is 1100. Okay, so then what else do I need to do? I guess I need to now figure out what happens if I go all the way to the International Space Station. That means this goes to 400. So now let's go and do it again. I'll draw the Earth. Is that okay for a circle? Close, sort of. Now we're at 400 away. We'll draw the radius, 6,000. And we'll try to draw this tangency point. Should go a little bit further this time. Maybe something like this. And so this would be 6,000. So now what do? I do the same thing again. Let's just go and figure this out. This happens to be, I'll call it 100 times. We'll already save ourselves drawing another picture. That doesn't quite look like a right angle. Right angle. This is 64 and 60. But if that's the case, I could actually divide out even more. I don't think I want to stop by just dividing out 100. Let's divide out 400, right? Or yeah, I think I'll say that. Let's divide out 400. And if I divide out 400, the 60 becomes 15. And the 64 becomes 16. Now, unfortunately, there's no nice right triangle, which is 15, 16. And if I wanted to know what this was, I would get square root of 16 squared minus 15 squared, which is equal to the square root of 31. There's something nice when you subtract two squares. The answer is the smaller one. Sorry, if you subtract two squares that are right next to each other, then the answer happens to be the smaller one plus the bigger one, I think. 256 minus 225 looks good. Okay, so root 31, and then I have to times 400. Now, unfortunately, that's not going to be a nice number. Is there anyone here with a calculator who can tell me what 400 times the square root of 31 is approximately? 200 root 31. Are you sure? I think it's 400. But let's find out. 400 root 31 is 2227.1. Okay, so what's the ratio approximately? The ratio approximately is 2227.1 divided by 1100. What's that, approximately? If I divide by 1100, 2227.1 divided by 1100, I'm going to say that's approximately 2. And that's another way. Oh, you're telling me the answer is 2.02? Wow, really? Yeah, I see that. It's about 2.02. It's really close to 2. And now, let's take a step back. Is there a good reason why it should be close to 2? You see, this question was chosen for a reason. Look, we did all this hard work. In the hard work, we did get to learn about the 11, 60, 61 right triangle, so that was good. But why is it so close to 2? Well, it's because of this. Aha, I see somebody said square root of 400 over 100 is about 2. Let me try to draw another circle. Close enough, okay? Now let's suppose we go out by x. And suppose that this is the 6,000. Oh, I don't want to call it 6,000 anymore. I want to call it r. R for radius, okay? Now let's draw the same picture we had before. Like this. This is r. And the other one is the square root of r plus x, whole thing squared, minus r squared. Is this okay? This is exactly what we did. We just took this r plus x, whole thing squared, and minus the r squared. That's all we had. Now, if I have this, what happens if I try to simplify? Look what happens. I get the square root of. All right, I need some help. What's r plus x whole thing squared? This thing we've seen a lot in all of the streams that I happen to do every day. But if you try to multiply r plus x by r plus x, you actually get r squared plus 2rx plus x squared. And then you minus an r squared. That's interesting. If you do this, what happens? The r squared and the r squared cancel. So this becomes the square root of 2rx plus x squared. Now here's where things get interesting. I'm actually going to factor an x out of this. And at first it will look kind of weird. Why in the world will you do this? We'll find out soon. Square root of x times root of 2r plus x. Okay? So now let's start to think about what's actually happening. I want to know a ratio. I want to know what happens when x is 400 and when x is 100. Okay? So if I go and do this where x is 400 and I divide it by what happens when x is 100, what happens to the ratio? When x is equal to 400 divided by when x is equal to 100, that's equal to the square root of 400 times the square root of, now let's remember how big r is. R was 6,000. So it's 12,000 plus 400 divided by the square root of 100 times the square root of 12,000 plus 100. And here's where that 2 comes from. This square root of 400 divided by the square root of 100, that's equal to 2 times something like this. Root of 12,000 plus 400 over root of, oh, let's just write down what they actually are. It's the root of 12,400 divided by the root of 12,100. And you see, this is basically 1. This is very, very close to 1. If I take 12,400 and 12,100, even though they differ by 300, as a ratio, it's almost 1. And so if I take the square root, that's even closer to 1. And so this happens to be basically approximately 2. And that explains why this whole thing worked out. So the fastest way to solve this problem would actually have been to go and write this out, figure out the expression, and then just divide and find out that, oh, it's basically going to be the square root of 400 divided by the square root of 100, and that's about 2. And that's it. Okay, so that's this particular question. Hope that you thought it was somewhat interesting. This is actually what I was musing in my head about going to space and looking at the Earth from space. And I was just kind of curious, how far can you see? And it was quite interesting to me to just notice that somehow if you go 4 times as far away from the Earth, that is to go to the International Space Station, if the distances you're moving are already quite close to the Earth, if you started quite close to the Earth, quadrupling your distance from the Earth would only double the amount of distance you can see, which is kind of neat. Okay, great. So that finishes this particular part of the live stream, and that moves us now into the next part of the live stream. The next part of the live stream is just to answer questions that range across all kinds of things that you might be interested in. And the way that we do this is that I usually don't talk about I don't answer questions that have to do with things that you'd see anyway in the live streams during the week. And those are the ones where I answer questions about actually math. Here is where we answer questions about more general things. And I'm happy to see what you guys are interested in. Also, just a second, let me move this a little bit. Great. Okay. Yes, indeed. You are right. I am standing on a block of paper, and so I just had to move that block of paper a bit so that it was actually centered. Great. So what kind of questions do we have here? I'm going to pull up what we have from our moderating team as well. Okay, great. Cool Kid asked, did you see the SpaceX launch? Do you think this will change the world? I think it's very interesting because, as you know, somehow the government in the United States has not really been investing huge amounts of money to launch people into space. And so it can only be done by other groups like Elon Musk, I guess. And so to me, to be able to see that it was successful gives some hope that I guess human beings might find a way back up into space and to other planets and maybe to other stars at some point. We do need this kind of creativity. Also, I guess for me, it's really interesting to watch because SpaceX was started, it was started around the time that I graduated from college. And so there are quite a few people, I don't want to say it was started around then, but it hired a lot of people that went to college with me. And so there were quite a few people who were involved in the launch, who I actually had known from a long time ago. So it's wonderful to go and see their success. Other questions? P14Y3R0N3 asks, do you think celebrities get mobs of fans at their house? I think they do, but I think that's why a lot of celebrities have like private security or something. So I think it's quite hard to actually get into the celebrity's house. I'm not sure I'd recommend doing this. On the other hand, I think it's quite interesting also the notion of celebrity. I think that celebrity is an opportunity to try to do something good, try to do something impactful. And so my hope always is that whenever there's somebody who happens to be a celebrity, they think of trying to use it for something. Adit Ambadkar asked, how do I prepare AOIME? AOIME. So there's going to be an online math competition that's based on that's basically the AIME, which is this very, very difficult math competition that usually is done every March. And the question of how to prepare for this, again, I would say just go and play with the old questions. If it seems to you that somehow questions around 9, 10, 11, 12, 13, 14, 15 are all impossible, don't worry too much about them. Worry about the questions that are somewhat in the middle. And as you do the questions that are somewhat in the middle, you'll get stronger, and then you can move towards the questions at the end. I saw there was a question by Ray Zhang asked, when is Novid going to be in the App Store? And the answer is in -3 weeks. It was in there 3 weeks ago, and we're very happy that various people are indeed using them. I see that Judy Andy has asked, why am I getting alerts from Novid? Well, it's either that you actually are getting alerts because there are some people who are in your network who have reported positive, or it is that maybe we sent you an alert to update your app. And in fact, soon everyone will get an alert that to update the app because we've just used mathematics to go and significantly increase the accuracy of the distance sensing for the app. This is something that I was actually working very deeply on for the last almost week and a half or two. But that release will come out probably in about 3-4 days. So I have a question from Colin Z. Which would you choose? Pizza, taco, or hot dog? All three of these are kind of like junk food, right? So, I mean, in some sense, all three of these are potentially not very good for you. If I really was going to choose between pizza, taco, and hot dog, I would choose the taco, and let me explain why. The reason is because this office where I am right now doing this live stream, is just down the street from an amazingly good taco stand. The way you can tell that they're amazingly good is that the person who grills the tacos does it on the sidewalk. So there's this sidewalk grill where they make tacos. It's not inside some kind of a Chipotle or some kind of an inside thing. There's just this guy standing on the sidewalk with a grill, and he makes tacos. And there are all these people who are always coming to buy his tacos. And the way you know it's really good is that they have been shut down by the county health department at least twice. I mean, that's partly a joke, but somehow that's how you know that it's authentic, right? Somehow it's you know, when you go to a restaurant, this one isn't particularly let's just say not particularly shiny, but they just happen to make great tacos. And in particular, this particular taco place, they also happen to have actually healthy things that you can put inside the taco. Whereas somehow pizza, unfortunately, generally is not particularly healthy. And for hot dogs, I'm not entirely sure what the hot dog is made of in the first place. It is meat, but it's not clear what kind of fillers or mixing things that they've put in. And why is it pink anyway? That's some chemical. Okay, more questions. Somebody asked, why was the taco place shut down? It was health code violations. There were, let's just say it wasn't the most clean place. But in any case, it was authentic. Let's see, what else can we say here? Other questions. P14Y3R0N3. Do you guys have mobs of people at your office? Well, not yet. We have had people come to our office who are curious, but I'll say that we only recently really started to go and get for example, these live streams to get known by lots and lots of people. So it could be that when the world comes back to normal, maybe people will start to stop by our office. We'll see. We'll know that it really went big when someday during a live stream somebody knocks on the door of the office knowing that there's a live stream here. More questions. I do see there's some questions here that are about math problems like golden and silver ratios. Those are the best questions to ask during the weekday live streams, because that's when we just dig in and do math the entire time. I want to use this time to be able to answer more general questions about learning, about technology, or about whatever we could do. Okay. Ooh, interesting. Winter Rain asked, opinions on Dyson spheres. And Winter Rain explains to me, these are huge megastructures that completely cover the sun and are able to harness all of the power that's in the sun. You know, I'll tell you something I was thinking about lately, actually as I was watching the SpaceX launch. As I was watching all of this, I was thinking, it's really interesting what we can do as human beings when we work together and when we try to do something that's good and when we get along. I was thinking about this because people also have talked about things like space stations, right? We know about the International Space Station. And then there are these interesting concepts of all these interesting things you could build in space, like spinning space stations with artificial gravity. All of these are exciting. But then even the Dyson sphere, like some huge megastructure that covers the sun and extracts all of the energy. These are all really interesting. But the only way that they'll work is if everyone actually gets along and tries to not break things, tries to not cause trouble, tries to not destroy the work that other people have made, and actually tries to work together to build something. A Dyson sphere would only work if somehow people on the Earth or the human civilization became more peaceful and really wanted to collaborate to go and make this thing work out. Because all you need is one bad person to go and attempt to destroy the Dyson sphere. And that would just be awful. So when I think about these things, I think about how far we have to go as humanity to move towards that point. And it also makes me realize that's why we have a lot of work to do to try to build this more harmonious civilization. Other questions? Okay. There was a question about general learning. Have you done Model UN? So I have never done Model United Nations myself before, but I had friends who did. And I do believe that those kinds of experiences are useful. When you are in school, if you're in middle school or high school, all of these things you can do in your clubs that help to build other kinds of skill sets are actually really useful. Because in the end, if the only thing you can do is math and science, you also can't do too much. So if you are interested in this Model United Nations, I'd say go for it. I think that you can learn a lot from there. The real United Nations, I think, is quite a bit more contentious, actually. But it's always good to learn, I guess, in a more friendly environment like school. Interesting questions that we have here. Somebody asked, what kind of computer do you have? I already answered this in the previous one, but briefly speaking, I put some parts together to go and make the computers that we use, for example, for this live streaming. Aha. Other questions. Ooh, This is interesting. Kyle Hongran He. What do you think every person should achieve in their life? I think something that would be good to achieve in your life is to have done something. Doesn't have to be huge, but done something so that, at some point at the end of your life, you will be able to look back and say, I'm actually happy that I did those things. I think that the goal that all of us should have is to at least live a life that we can look ourselves in the eye. I don't know what that means. I guess that means look yourself in the mirror. But basically look yourself in the eye and say, this is actually something that was worth doing. Because there's one person that you shouldn't be able to fool, and that's yourself. You should know to yourself whether you've done something that's worthwhile or not. And so the goal is, towards the end of your life, have stuff that you can look back on and say, that was actually worth it. And why I gave you that answer is because everyone has different values in this world. Everyone has different things they care about. I am not here to tell you what you need to do, but I'm just trying to tell you, know what you believe in, know what you think is worthwhile, and then be true to yourself. And then don't just do things that deceive yourself and maybe make you not able to achieve that, and then you'll have regrets at some later point in your life. Another question that came, somebody asked, how many people have downloaded Novid so far? The answer is we've had more than 30,000 people. And I'd say that's not bad, given that apparently, there are other apps that people have been trying to put out. And so it seems like Novid is doing pretty well, in the sense that without any kind of national news coverage, there were a lot of people who saw that this is valuable. I see Andrew Chow has asked, what is your least favorite subject? I think that all learning is actually very interesting. So if there has to be a least favorite subject, it would have to be something where I might not have been learning. But it's hard to think of what that would be, because even gym class is interesting. Like gym class is fun too. I don't know. I actually just really like learning. I guess to me, as long as... I'll tell you. Study hall. Study hall. I did not like study hall. Study hall is a subject in high school, which is called when you have nothing else to do, you go sit in a room with all these other people, and you're just sitting there, and it's like, I could do that stuff at home too. But somehow, study hall, not a big fan of study hall. Lin Cho says, cheerleaders. What does that mean? Is that a question? Although if you're curious, there is a video on YouTube with me and a cheerleading squad, and we're having some fun, and I'm attempting to do some cheerleading while talking about some math. Right, I see there are a lot of people asking, did I hear about George Floyd? And the answer is yes, of course. I mean, I think these are major, deep issues that we all have to confront as a society. This is supposed to be about math, but I guess we can also talk about, what are we trying to do with all these skills anyway? The key thing to know is whenever you have any ability or have any power, the power can be used for good, it can be used for not good. And so my take on all of these tensions are always that all of us, hopefully we're all learning some skills, and hopefully at some point in our life, we'll all be able to use those skills to do something that's positive. And that's my comment on that topic. Samuel Ding, does learning a different language help you in the future? Yes. I did not really know this earlier in my life, because I said, look, I live in the United States, I'm growing up in the United States, I'm going to go to college in the United States, I'm going to stay in the United States, and when I went to Europe for a year, okay, that wasn't the United States, but I went to England, and they all spoke English, obviously. In fact, they spoke better English than me. They thought my American English was weird. I guess they did invent English. And then I also found out as you go around Europe, even though you might not speak Italian, somehow they speak English. So I just sort of felt, seems fine, English can get you just about anywhere. But in the last 3 years, I got very interested in trying to work also with people in China. And so I discovered that somehow, since early on in my life I had learned some Chinese, this was actually quite useful. And so today I've actually tried to spend a lot of time learning both English and Chinese so that I can work with 2 billion people if I wanted to, right? There's like more people that you can communicate with. And you might say, well, come on, everyone in China is also learning English, so you could use English to communicate with them. The new generation in China is indeed learning English. However, if you actually are able to talk to someone in their native language, you often find out that you can communicate even better. And so sometimes, for example, nowadays, because I have practiced Chinese more, nowadays I often will communicate with people who are natively from China in Chinese, just because it's more convenient for them, and I find it more efficient for communication. For you, I hope that you will pick up some other language. Doesn't have to be Chinese, just like some other language. It's useful. You can then communicate with more people. All right. I see that some people here know how to type in Chinese too, which is pretty good. Somebody wants me to define a potato. Well, I'll say a potato is like the circles that I drew that aren't very good. Okay, more questions. Judy Andy asked, can you talk about how you came up with the idea of building Novid? So Novid, in case you guys don't know, is something that is trying to stop the spread of COVID-19. It's an app, and it detects if somebody nearby has the app so that we build this anonymous network of who has been around who, and then we want to use this anonymous network to prevent the spread of COVID-19. Because if, for example, we see that there's a bunch of people who are all positive, we would start to tell people who are somewhat close to them on the network that they might want to be careful, that the COVID-19 is spreading towards them, and in 1 week they might have a tsunami hit their neighborhood, tsunami of cases. So that's what I saw could actually help. And why I got involved, I can tell you the story actually. I don't know if I ever told this group the story. The story is like this. So I actually, as you know, do math and math education. In fact, I was just going and making this live stream for YouTube. I was doing online classes with our daily challenge course. I was just doing all that stuff. But then in the middle of March, I got an email. I got an email because a long time ago when I did my PhD, the PhD was funded by a group called the Hertz Foundation. That noise is a helicopter. And unfortunately, the helicopters here are all going to hospital. So every time we hear one of those helicopters, it unfortunately means there's somebody who needs an emergency evacuation to a hospital. Right. But so, my PhD was supported by the Hertz Foundation. And the Hertz Foundation is a group which looks for 15 very, very good scientists, engineers, and mathematicians across the United States every year and gives them funding for a free PhD, except that they have to sign something that says if there's ever a moment of national emergency, they'll come to help. So the goal of this was to always have a big bank of scientists and engineers so that if there's a national emergency, then there will be people who could come together and try to do something. And so I actually got that. I'm one of these people. So I got this thing in 2004. And so there was a message that went out to this community in March that said COVID-19 is this national emergency. If there ever was one, this is the national emergency. And so, I got mobilized. I got activated. And so I started thinking, what could I do? And this is what I came up with. All right. More questions. Oh, interesting. What was your favorite subject in middle school? So I will say, you probably can guess. It was math. I'm here surrounded by math symbols. I actually think that math is the fundamental subject, but that's underneath just about anything. So I'll tell you a fun story. I was just talking to some professors at a university, a fairly reasonable university that I won't put the name on, but I was talking to these people last week about Novid, because we were trying to have a way to help universities be able to have their students come back. And what we were talking about was like technology, cryptography, security, and all of these things. And as we were talking about all of this, at some point the other professor said, yeah, mathematicians can do anything. This is actually this is an opinion I share also. I think that if you really learn the math very solidly, if at some point in your life you decide that you want to learn how to program an iPhone, you can go and learn how to program an iPhone relatively quickly. And before you know it, you might actually be better at programming the iPhone than people who just didn't have as strong of a mathematical background. So I will say that my favorite subject for a very long time was always math, because I saw that as the truth. We were always hunting for the truth and trying to understand it. But at the same time, I also think it's really useful to understand how the world works. And if you try to figure out how the world works, like I'm talking about physics or I'm talking about engineering, then you can combine that with the math and you can do a lot. What other questions? I see that we've gotten a lot of these questions, how to be good at mathematics. And I do answer this question, but it's been a while since I said the answer, so I'll say it again now. The way is to not just memorize things. I just told you I liked math in middle school, but I didn't learn it by just memorizing how to do problems. I learned the math by fighting with questions that were just a bit too hard for me, and by doing so, learning how to come up with my own ways to crack those questions. That's why on this weekend live stream, I chose to give you problems that are, a little bit out of your range, but are things that, if you have a few hints, you might be able to solve. Do that with the way you learn all the math. What other things? Oh, interesting questions. Wow. So I'm just looking at all of these and trying to pick what are these things. Okay. Moonwatcher123. If you could make any other app, which would you make? I'll give you an answer that's not an app. I'll give you an answer that's actually another major problem that I have been thinking about. It's called universities. There's a huge problem right now, and it actually directly affects me. All of these universities in the United States are trying to figure out what to do for fall or for spring. And not only universities, of course, schools have to worry about this too. But there's a difference between schools and universities. In the United States, a lot of universities are fairly expensive. There's a lot of tuition. And so a lot of universities in the US need to actually have classes, or else there will be big problems. So I've been thinking, there's actually a solution. This is a crazy idea. But you heard it here first. I think that you could have universities partner with cruise lines. And then what you do is that each of the universities goes and gets a cruise ship. And then they just put all of the students on that cruise ship and send them off for 2 years. I mean, this is half a joke and also half serious. What I'm trying to say is there's something important that happens first. You first have a series of hotels that you put them on, that you put the students on, which are like in a sequence of islands. It's almost like how you filter water. And you've got island number 1, island number 2, island number 3. You get to move from one island to the next island every month. And by the time it gets all the way through, and like you're through 5 islands, there's no one there with COVID-19. At that point, they all get on the cruise ship, which is sized for a few thousand people anyway, no COVID-19 whatsoever, and they just go out for like 2 years, and that's much better. That's what you're doing in college anyway. So that's like half a joke, and also half like, if somebody thought about this, they might actually be able to solve the problem for all universities in the US. There are a lot of empty cruise ships right now. People are asking, would it cost a lot? Sure it would, but in the United States, so does college. So anyway, that's just a funny thought. But I wanted to tell you this because it's just showing, maybe somebody else, maybe one of you will have a crazy idea someday. Most of the time, the idea will be bogus, and in fact, what I just told you might have been bogus. But you have to keep asking these questions, and at some point, if you come up with a good idea, then do it. Okay. So, unfortunately, we've actually gotten to 8:45. And I see that people here seem to really want me to sing and dance. But right now, I'm actually in the middle of really trying to get our next thing out for the iPhone. So unfortunately, we're not going to do that one today. On the other hand, I want to thank all of you for joining us, for tuning in for this weekend's math show. I guess they're all called Study at Home. I thought we used to call them Saturday Night Live, but I guess they're called Study at Home now. In any case, thank you for joining. I hope that you guys all had some interesting experience. Again, the goal of today was not to teach a particular math, apart from that question we talked about, but rather to also talk about all these broad questions that are part of being a person and part of like how we approach life. And it's fun to be able to talk to all of you, hopefully to help you build those fundamental skills on math, and hopefully also to help everybody use those skills to do something actually good. All right. Well, have a good evening, everyone. We won't have a show tomorrow, but we'll be back on Monday. See you.